Hello dear students, welcome to EPG Pathshala. I am Dr. DC Saxena, Professor and Head of the Department of Food Engineering and Technology at Sant Longowal Institute of Engineering and Technology, Longowal. I am presenting you the paper Technology of Spices and Condiments, and the present module will tell you about the chemical composition of different spices and condiments in detail by co-author Ms. Syed Insha Rafiq, who is well versed with this topic.
Hello students, welcome to EPG Pathshala. I am Syed Rafiq from Sant Longowal Institute of Engineering and Technology. Today I am going to talk about Module 6 of paper number 10, that is Technology of Spices and Condiments. In this module, we will be learning about the chemical composition of spices and condiments. Spices are the natural aromatic compounds with a varied chemical composition, having terpenes, monoterpenes, phenol, pinene, etc. While condiments are prepared flavored compounds whose composition depends upon the raw material from which they have been prepared, like sauce, ketchup, chutney, etc. The common application of spices in foods is as flavoring agents. The active components in the spices, including polystyrene, phenolic acids, flavonoids, coumarins, triterpenoids, sterols, and monoterpenes, are powerful tools for promoting physical and emotional wellness. Spices, in addition of providing flavoring properties, also act as antioxidants due to their antioxidant properties of their constituents. Some of the spices possessing antioxidant properties include cumin, that's having highest antioxidant activity, then turmeric due to curcumin constituent present in it, then cloves, ginger, garlic, etc., also possessing antioxidant properties. In addition to this, spices also possess anti-tumor, anti-inflammatory activities, antibacterial, antifungal, antispasmodic, anethol, antioxidant, and insecticidal properties, and in addition to these, pharmacological active substance due to varied chemical constituents present in the spices. Turmeric. Turmeric is an antioxidant phytochemical known as a polyphenol and has a chemical composition of C21H20O6. It contains a mixture of phenolic compounds called curcumin, about 5%, and related compounds called curcuminoids, and a volatile oil, about 5%, with termerone and zingiberine. In addition to the above compounds, there are certain other components like phenol and other monoterpenes, starch, protein, and high amounts of vitamin A and other vitamins like vitamin C and E, several carotenoids. The oil present in the rhizome is responsible for the aromatic taste and smell of the rhizome and consists of alpha-phenidine 1%, saponine 0.6%, phenol 1%, bornine 0.5%, gingerberine 25%, and sesquiterpene 53%. However, ketonic sesquiterpenes are termierone responsible for the aroma of turmeric. Functions may include curcumin is one of the antioxidants. Cineol stimulates central nervous system and is antiseptic. Essential oil has stimulating effects on the gallbladder and also stimulates the liver to produce more bile and regulate its viscosity. Curcumin exists in two forms, keto and enol. Keto form is preferred in solid phase while enol form in solution and is a pH indicator as it turns yellow into acidic solution and bright red in basic solution. Coriander. Leaves and seeds contain several essential volatile oils like bonyl, linalool, cineol, cymene, terpenoil, dipentene, phenolidine, pinene, and terpenoid. In addition to this, they are also rich in varied antioxidant polyphenolic flavonoids like quercetin, camphorol, rhamnitine, and epigenine. Fruits contain fiber about 23 to 36%, carbohydrates about 20%, fatty oil about 16 to 28%, proteins about 11 to 17%, and 0.2 to 2.6% volatile oil. Other constituents present in fruits include up to 26% fats made up of glycerides, primarily of oleic, petroleic, and linolenic acids, a small amount of unsaponifiable matter containing beta-stosterol and alpha-stosterol, triacontanol, tricosanol, etc. Proteins about 11 to 17%, about 1% starch and 20% sugars, coumarins, flavonoid, glycosides, and rutin. The major component of the oil is D-linolol coriandrol, which is present in 55 to 74%. Other compounds present in the oil include decylaldehyde, borneol, geraniol acetate, camphor, cardamom, anisole, caryophyllene oxide, elimol, and monoterpene hydrocarbons, mainly gamma terpene and alpha and beta pinene, D-limonene, P-cymene, beta-phenidine, and camphene. Leaves contain less volatile oil than fruits, about 5% fats, about 22% proteins, sugars, coumarins, and flavonoid glycosides similar to those in fruits, vitamin C, and others. The volatile oil contains mainly decyl and anoyl aldehydes and linolene, among others. Functions include the plant yields two parts that are used for flavoring purposes, the fresh green herb and the spice. However, the odor and flavor of these two products are different. Fennel. The fruit contains mucilage, sugars, starch, tannin, fixed oil, and essential oil. The main chemical components of fennel are alpha-pinene, myrcene, phenycreone, transanisole, methylchavicol, lamoline, 1,8-cineol, and anisic aldehyde. Fruits contain 1.5 to 8.6% volatile oil, 9 to 28% fixed oil, composed primarily of petroleic acid, about 60 to 75% oleic acid and linoleic acid, with a relatively high concentration of tocopherols. Flavonoids mainly quercetin, 3-gluconide-lutein, isoquercetin, and quercetin-3 arabinoside. Proteins about 16 to 20%. Sugars, vitamins, minerals, and others. Low concentrations of polystyrenes were recently detected in the root. The volatile oil contains mostly trans-enethol 72 to 74% with lesser amounts of phenochrome 11 to 16%, estradiol, methyl chavicol 3 to 5%, limonene, camphene, and alpha-pinene. Other compounds present include monoterpene hydrocarbons, beta-pinene, alpha-theogen, alpha-phenylene, 3-carene, sabenine, alpha-phenidine, myrcene, alpha and beta-terpene, terpinol, and p-cydamine. Phenyl alcohol. Functions include phenol contains enethol and antispasmodic along with other pharmacologically active substances. Chemical category of fresh fennel. 24 constituents were present in fennel, which constitute 97% of the total essential oil components. Phenol ethers was the main chemical category, about 72.7%, followed by monoterpene hydrocarbons, 17.6%. The major essential oil constituents were trans-enethol, about 55.5%, followed by isoenethol, 17.2%, alpha-phenidine, 10.3%, phenochrome, 5%, and alpha-pinene, 3.4%. Here, the chemical category and percent composition is given as monoterpene includes hydrocarbons about 17.6%, ketones about 5%, esters about 0.6%, phenols and phenol including ethers about 72.7%, sesquiterpene including hydrocarbons about 0.1%, and unknown substances about 1.3%. Total compounds identified are about 97.3%. Fenugreek contains simple alkaloids consisting mainly of trigonylane up to 0.13%, choline 0.05%, gentine, and carpene. Other constituents include saponins that yield on hydrolysis 0.6 to 1.7% steroid, flavonoids including vetexin, fixed oils about 5 to 8%, consisting mainly of linoleic, oleic, and linolenic acids. Considerable amount of mucilage, which appears to be mostly a galactomannan and is probably responsible for swelling of the seed in water. Protein about 23 to 25%, which is low in sulfur amino acid but high in lysine and tryptophan. In addition to the above constituents, the other constituents include free amino acids including 2S, 3R, 4R, 4-hydroxyisoleucine, histidine, lysine, and arginine. Vitamins, especially vitamin A, B1, and C. Minerals, especially calcium and iron. Volatile components more than 50, which include N-alkenes, sesquiterpene, and oxygenated compounds. Garlic contains more than 200 chemical compounds. Some of the important ones include volatile oil 0.1 to 0.36% with sulfur-containing compounds, allicin, aline, and arginine. Protein 16.8%, and enzymes alinase, peroxidase, and myrosinase. Allicin is what gives garlic its antibiotic properties and is responsible for its strong odor. Garlic also contains citrol, geraniol, linalool, A-flandine and B-flandine. In addition to this, it also contains phosphorus, potassium, sulfur, selenium, calcium, magnesium, germanium, sodium, iron, manganese, and trace iodine. 17 amino acids are found in garlic, including 8 essential ones. Cloves are actually the dried buds of the clove tree. The minor constituents like methylamyl ketone, methyl salicylate are responsible for the characteristic pleasant odor of cloves. Clove oil is comprised of many different compounds, with the primary compound being eugenol, about 49 to 87%, beta-caryophyllene 4 to 21%, and eugenyl acetate 0.5 to 21%. Smaller amounts of alpha-humulene, methyl-eugenol are also present, as well as traces of less than 1% of 25 to 35 other constituents. Cloves also contain flavonoids, gallotannins, phenolic acids, and triterpenes. Several factors govern the relative quantities of the different constituents in clove oil, including plant genetics, climate, soil, and cultivation techniques, the part of the plant extract, and the extraction method. Functions include its having antibacterial, antifungal, antioxidant, and insecticidal properties. Clove oil is an active ingredient in several mouthwash products and a number of toothache pain relief preparations. It's also used to disinfect root canals. Among the spices, cumin is having highest antioxidant activity, and these antioxidants also act as preservatives by preventing or slowing the spoilage of food. Cumin fruit is a strong, heavy, and warm substance with a distinctive bitter flavor and a strong, warm aroma due to their abundant essential oil content. The essential oil content of cumin seed ranges from 2.3 to 5% and consists of hydrocarbons about 30 to 50%, aldehydes and ketones about 50 to 70%, alcohols 2 to 5%, and ethers less than 1%. Among the sea spices, cumin fruits have a distinctive bitter flavor and strong, warm aroma due to their abundant essential oil content. Cumin aldehyde, about 40 to 65%, is the major constituent and important aroma compound. The characteristic flavor of cumin is due to the presence of monoterpenes such as alpha-pinene and cis-beta-farnesene. The composition of Indian cumin oil, which contains less cumin aldehyde, is cumindehyde 15 to 40%, terpenes 18 to 29%, alpha-pinene 1.3%, beta-pinene 2%, cineol, beta-cymene, and limonene, and menthodiol 30%. Functions are: among the spices, cumin is having highest antioxidant activity, and these antioxidants also act as preservatives by preventing or slowing the spoilage of food. It's used to treat hoarseness, jaundice, dyspepsia, and diarrhea. Its seeds have stomachic, diuretic, carminative, stimulant, astringent, and abortifacient properties. The color of chili spice powder is due to the presence of red pigmented carotenoids. The main pigments are capsaicin, capsorubin, zeaxanthin, and cryptoxanthin. Capsaicin, the major carotenoid in ripe fruits, contributes up to 60% of the total carotenoids. Capsaicin and capsorubin increase proportionally with advanced stages of ripeness, with capsaicin being the more stable of the two. Pungency of chili is attributed by a group of alkali compounds like the capsaicinoids, and there are 5 natural capsaicinoids, which are capsaicin, dihydrocapsaicin, non-dihydrocapsaicin, vanillide, decaamide, and homodihydrocapsaicin. Capsaicin and dihydrocapsaicin are the main capsaicinoid in chili pepper, while non-dihydrocapsaicin, homodihydrocapsaicin, and homocapsaicin are the minor capsaicinoids. Capsaicin is synthesized in interlocular septum of chili pepper and is made from vinylamine and 8-methyl-6 non-nonyl-CoA. In paprika, the volatile oil in the fruits range from 0.1 to 2.6%. The characteristic aroma and flavor of the fresh fruit is imparted by volatile oil. Pepper gets its spicy heat mostly from pepperine compound, which is found both in the outer fruit and in the seed. Black pepper contains between 4.6% and 9.7% pepperine, while white pepper contains slightly more than that. Black pepper contains 2 to 4% volatile oil and 5 to 9% pepperine, piperidine, and a few minor alkaloids: piperylene, piperidone A, piperidone B, piperidine, etc. Piperine and piperidine are the known pungent principles. Black pepper oil contains beta and alpha pinene, alpha limonene, and beta cardiophyllene as major components. Black pepper is also reported to contain flavanol glycosides, especially those of camphorol, rhamnitine, and glutathione, in considerable concentration, as well as sterols, stigmastan 3,6-dione and stigmast 4-in-3,6-dione, and polysaccharides. White pepper contains little volatile oil but has the same pungent principles and alkaloids as black pepper. Both also contain about 11% protein, 65% carbohydrates, lipids, crude fiber, and others. Pepper oil contains a complex mixture of monoterpenes 70 to 80%, sesquiterpene 20 to 30%, and small amounts of oxygenated compounds, with no pungent principles present. Major monoterpenes include alpha-theogen, alpha-pinene, camphene, sabanine, beta-pinene, myrcene, 3-canine, limonene, and beta-phenidine. Sesquiterpenes include beta-cardiophyllene, major component, beta-bisubline, beta-farnesene, curcumin, humulene, beta-selenine, alpha-selenine, beta-alanine, alpha-cubigene, alpha-copene, and sesquiosabenine. Oxygenated components include linoline, 1-terpene, 4-all, myristicin, beta-pinone, etc. Composition of black pepper. There are 15 monoterpene hydrocarbons identified so far, and they are caffeine, alpha-3-carine, beta-cymene, limonene, myrcene, cis-ocimene, alpha-flandine, beta-flandine, and alpha and beta-pinenes, sabanine, alpha and gamma terpenes, terpenol, and alpha-thujine. Beta-cardiophyllene is a major cis-terpenes hydrocarbon present in pepper oil. Miscellaneous compounds include eugenol, methyl eugenol, myristicin, safrole, benzaldehyde, transenethol, pepperonol, M-methyl acetophenone, P-methyl acetophenone, and butyrophenone, benzoic acid, phenyl acetic acid, cinnamic acid, and pepperonic acid are some of the aromatic compounds characterized in pepper oil. Chemical category and percent composition of pepper is as: terpenes include alpha-thujone about 0.22 to 3.59%, alpha-pinene about 1.11 to 16.2%, camphene 0.23 to 1.44%, sabanine 0.14 to 13.78%, beta-pinene 4.92 to 14.33%, beta-flandrine 0.46 to 27.37%, myrcene 1.66 to 2.53%. Then cis-terpenes include beta-cardiophyllene 9.39 to 30.94%, beta-farnesene 0.03 to 3.26%, beta-bisabine 0.09 to 5.18%, translinolene 0.04 to 0.25%, alpha-terpenene 4-all 0.01 to 0.18%. The curry leaf plant is highly valued for its characteristic aroma and medicinal value. There are a large number of oxygenated mono and cis-terpene present. For example, cis-ocimene about 34.1%, beta-cardiophyllene about 9.5%, alpha-pinene 19.1%, alpha-terpenene 6.7%, and beta-flandrine, which appear to be responsible for the intense odor associated with the stalk and flower part of curry leaves. A number of leaf essential oil, constituents, and alkaloids have been extracted from this plant. Ginger owes its characteristic organoleptic properties to two classes of constituents. The aroma of ginger are due to the constituents of its steam volatile oil, which are mainly cis-terpene hydrocarbons, monoterpene hydrocarbons, and oxygenated monoterpenes, while its pungency is due to the non-steam volatile components, also known as the gingerols. The major cis-terpene hydrocarbon constituent of ginger oil is alpha-gingiberine. Certain ginger oil has a reputation for possessing a particular lemony aroma due to its high content of the isomers nerol and geranyl, often collectively referred to as citrol. The antioxidant components analyzed were polyphenols, vitamin C, beta-carotene, flavonoids, and tannins. Functions include: ginger is said to have antioxidant and anti-inflammatory activities. It is believed to have anti-tumor removing activity. Let's now talk about large cardamom. The chemical composition of large cardamom differs with variety, region, and age. The seeds contain 3% of essential oil and 5 to 7% of monoterpene hydrocarbons. The major constituent of the essential oil is 1,8-cineol, that's 65 to 80% present, and minor being A or alpha terpenyl estate, that's about 5%. The monoterpene hydrocarbons are limonene, sabenine, terpenine, and pinene, and these are significant components present. The terpenols comprise approximately 5 to 7% of the oil. The volatile oil, that is high cineol and low terpenyl acetate, or the principal aroma giving compound in the large cardamom. Then moving to functions of cardamom. They are used in conditions like indigestion, vomiting, enlarged spleen, abdominal pains, rectal disease, and mouth infections. The seeds of or the seed extract of large cardamom acts as a tonic for the heart and liver, is a bowel estrogen, and has hypnotic and appetizing properties. Cardamom skin is used for headache, tooth ailments, and stomatitis, and its oil is applied to the eyelids, allaying inflammation. Small cardamom. The chemical composition of cardamom differs considerably with variety, region, and age of the product. The volatile oil contains about 1.5% alpha-pinene, 0.2% beta-pinene, 2.8% sabenine, 1.6% myrcene, 0.2% alpha-fluindrine, 11.6% limonene, 36.3% 1,8-cineol, 0.7% gamma-terpenine, 0.5% terpenylene, 3% linolene, 2.5% linolide estate, 0.9% terpenyl 4-ol, 2.6% alpha terpenyl, 31.3% alpha terpenyl estate, 0.3% citronellone, 0.3% nerd, 0.5% geraniol, 0.2% methyl eugenol, and 2.7% transmurolidol. Cardamom seeds also contain fixed oils, which are constituted mainly by oleic and palmitic acids. Functions include cardamom essential oil is having anti-inflammatory, antimicrobial, antiseptic, carminative, digestive, diuretic, stimulant, stomachic, tonic, and antispasmodic properties. Cinnamon. The dried bark of C. zelenicum contains 59.5% carbohydrates, 20.3% fiber, 9.9% moisture, 4.6% protein, 2.2% fat, and 3.5% total ash. It also contains 1.6% calcium, 0.05% phosphorus, vitamin A 175 IU, vitamin B1 0.14 mg per 100 gram, vitamin B2 0.21 mg per 100 gram, vitamin C 39.8 mg per 100 gram, and niacin 1.9 mg per 100 gram. The dried inner bark of cinnamon and cassia contains volatile oil, fixed oil, tannin, resin, proteins, cellulose, pantothenic, mucilage, starch, calcium oxalate, and mineral elements. Cinnamon possesses a delicate, spicy aroma which is attributed to its volatile oil. Volatile components are present in all parts of cinnamon and cassia and comprises of monoterpenes, sesquiterpenes, and phenylpropenes. The major component of leaf oil is eugenol, while that of bark oil is cinnamaldehyde. The oil from the stem bark contains 75% cinnamaldehyde, 5% cinnamyl acetate, 3.3% cardiophyllene, 2.4% linolein, and 2.2% eugenol. The leaf oil contains 99.96% of the oil. The main constituents were eugenol 76.6%, linalool 8.5%, piperitone 3.31%, eugenyl acetate 2.74%, and cinnamyl acetate 2.59%. Functions include: the oil is used in perfumery and flavoring. The bark is used widely as a spice. It's used for flavoring baked products such as cakes, biscuits, puddings, chewing gum, and desserts. It's used as an ingredient in many Ayurvedic and Unani medicinal preparations. The bark is an aphrodisiac, anti-emetic, and tonic. Among condiments, vinegar is a liquid substance consisting mainly of acetic acid, that is CH3CO2H, and water. Acetic acid is produced mainly through the fermentation of ethanol by acetic acid bacteria. Generally, vinegar contains extract, ash, volatile acid, non-volatile acid, reducing sugar. The concrete substances present are higher alcohols, that's 3-hydroxybutanoate, dihydroxyacetone, tyrosol, acetaldehyde, formaldehyde, acetal, acetic acid. The content is about 3 to 5%. Succinic acid, oxalic acid, and sorbose. Thick sauce consists of water, protein, fat, carbohydrate, ash, calcium, phosphorus, iron, thiamine, oeflin, nicotinic acid. In every 100 gram of thick sauce there are water about 39 gram, protein 20.9 gram, fat 11.2 gram, carbohydrates 2 gram, ash 24.9 gram, calcium 245 mg, phosphorus 174 mg, iron 16.1 mg, thiamine 0.05 rag, oeflin 0.78 mg, and nicotinic acid about 2.1 mg. Hot sauce. There are many recipes for hot sauces, the common ingredients being any kind of chili pepper. A group of chemicals known as capsaicinoids are responsible for the heat in chili peppers. The peppers are infused in something from vinegar, oil, water, beer, and alcohol to fruits and vegetable pulp. Additional ingredients are often used, including those used to add extra heat, such as pure capsaicin extract and mustards. Olive oil is basically a fat obtained from the olive fruit. The oil is produced by grinding whole olives and extracting the oil by mechanical or chemical means. Chemical constituents of olive oil. It contains of saturated fats in the proportion as palmitic acid about 7.5 to 20%, stearic acid 0.5 to 5%, arachidic acid less than 0.6%, behenic acid less than 0.3%, myristic acid less than 0.05%, lignoceric acid less than 0.2%. The monounsaturated fats present are oleic acid about 55 to 83%, palmitoleic acid 0.3 to 3.5%, linoleic acid 3.5 to 21%, and alpha-linolenic acid about less than 1%. Mustard. Mustard is usually used at the table as a condiment on meat. The nutritional value per 100 gram is as energy is about 276 kilojoules or 66 kilocalories, carbohydrates are 8 grams, sugar 3 grams, dietary fiber 3 grams, fat 3 grams, protein 4 grams, magnesium 49 mg or 14%, sodium 1120 mg or 75%. Table salt. It's comprised primarily of sodium chloride. It's a refined salt containing about 97 to 99% sodium chloride and anti-caking agents like sodium alumina silicate or magnesium carbonate to make it free-flowing. Some other anti-caking agents include tricalcium phosphate, calcium carbonate, calcium silicate, sodium alumina silicate, and calcium alumina silicate. However, additives may also be added. Iodine-containing compounds are added to table salt, like potassium iodide, sodium iodide, or sodium iodate. Small amount of dextrose is added to stabilize the iodine. Iodized salt is used to reduce the incidence of iodine deficiency in humans. Wasabi. The volatile for pungency is a group of chemical compounds like allyl isothiocyanate produced by hydrolysis of natural rhizome thioglucosides, and the reaction is catalyzed by myrosinase. 100 gram of wasabi root contains calories 109 kilocalories, fat 0.63 grams, carbohydrates 23 gram, fiber 7.8 grams, and proteins 4.6 grams. Ketchup. Ketchup has health benefits which are offset by the salt and sugar content. Ketchup is a source of lycopene, an antioxidant which may help prevent some forms of cancer. Nutritional value per 100 gram include energy 100 kilocalories or 419 kilojoules, water 68.33 grams, protein 1.74 gram, fats 0.49 gram, carbohydrates 25.78 gram, sodium 1110 mg, vitamin C 15.1 mg, lycopene 17 mg. Tamarind. It contains plant acids about 16 to 18% and is composed primarily of D-tartaric acid with minor amounts of L-malic acid. Other constituents include polyphenols, catechin, epicatechin, and prostaglandin, flavonoids, taxiphyllin, epigenin, luteolin, and naringenin, sugars about 20 to 40%, pectin, protein about 2.8%, fat, vitamins, vitamin B1 and C, minerals like calcium, potassium, phosphorus, etc., and tartrate. It also contains a volatile fraction that consists of over 60 identified compounds, including limonene, terpene, 4-all-nerol, alpha-terpenoyl, geranyl, and geranoyl, which are responsible for its stress taste. Methyl-salicylate, safrole, inones, beta and gamma, cinnamaldehyde, and ethyl cinnamate, which contribute to warm, spicy taste. Pepperitone and several pyroxene and alkyl thiazoles are also present. Vanilla. Mature, fresh green pods contain about 20% water and each 100 gram of dried pod contains on average 3 to 5 gram protein, 11 gram fat, 7 to 9 gram sugar, 15 to 20 gram fiber, 5 to 10 gram ash, 1.5 to 3 gram vanillin, 2 gram of a soft resin, and an odorless vanillic acid. Cured vanilla beans contain vanillin, organic acids, fixed fatty oil, wax, gum, resins, tannins, pigments, sugars, cellulose, and minerals. Vanilla contains 25% of sugars, 15% fat, 15 to 30% cellulose, and 6% minerals. Water content is unusually high, that's 35%. The main aroma compound responsible for the characteristic flavor and smell of vanilla is vanillin, that is 4-hydroxy-3-methoxybenzaldehyde, which is an aromatic aldehyde. Functions include: it's commercially used as a flavoring substance in ice creams, bakery products, and puddings. Its mellow fragrance enhances a variety of sweets and desserts: chocolates, custards, creams, souffles, liqueurs, ice cream, sugar cookies, puff pastries, and buttercreams. Its use in the perfumery and cosmetic. So students, let's now summarize what we have learned in this module. In this module, we have learned about the chemical composition of spices and condiments. Spices are plants with intensive and distinctive flavors and aromas used in fresh or dry form. They are a prized group of minor components in human diets. While used primarily as flavoring and seasoning agents in foods, many spices possess significant microbial activity. In all instances, antimicrobial activity is due to specific chemical or essential oils and spices reported to exhibit antioxidant and antimicrobial properties include rosemary, oregano, thyme, cinnamon, sage, clove, etc. The major antimicrobial components in cloves, cinnamon, and cassia have been reported to be eugenol and cinnamic aldehyde. Cinnamon is reported to contain 0.5 to 1% volatile oil, of which 75% is cinnamic aldehyde and 8% is eugenol. Cloves contain 12 to 21% volatile oil, which is 95% eugenol. It was found that cloves and cinnamon were only 2 spices out of 9 tested which have antibacterial activity. However, in some food formulations, both the spices and chemical antioxidants and antimicrobial chemicals are added. The inclusion of spices should ideally prompt reduction of these chemicals. Insufficient research on potent levels of spices in foods and advocacy to back up their antimicrobial and antioxidant are the main constraints to this. A lot of research have been done on antimicrobial and antioxidant activity of spices. It is surprising that with these substantial findings, spices are still branded almost purely as flavoring agents. Presently, spices are cheap and easily available even in countries where they do not grow. It is evidently a group of plants which has not been utilized in food technology despite its undisputed potential. That's all about the chemical composition of spices and condiments. Thank you.
So what is the chemical composition of different spices and condiments? You must have enriched your knowledge by now, which has been given to you by my co-author Ms. Syed Insha Rafiq. Now, the next module will be explained to you as spice, oil and oleoresins, its technology of manufacturing. Thank you.